All right, so we're starting a new topic today. We're looking at networks. And for this one, we're actually not going to use our textbook. I have found some other resources. I'll just quickly flick. These are resources that have been put together by the Department of Education for the Distance Education Unit. And, well, it's an alternative to our textbook, and I quite like it. What I've done is I've actually merged their separate units together. So this is the first kind of chunk of things, which is good 30 pages worth with all of the content that we need. But then I know these are only thumbnails and it's probably very small, but this is the first chunk and it goes through for whatever I said, 20 something pages. And then we've got the next chunk of things in there and the next one after that, and then the fourth one and a fifth one. Now, some of these are quite short, and the activities that they put in there are fairly short. I have actually included all of the answers at the back. But yeah, these activities are a bit shorter. What they've got is basically I'll try and find one for you. They've got each of the, get rid of that. No, there's some theory. Here's the exercise, and that is the entire exercise, just those two questions. But at the end of each chunk, there is an assignment, which is a longer section with a few questions from each type of thing. And I'm going to ask, I don't really need to worry about the smaller exercises, although I'm happy to help you guys with them. But what I'll probably do is set up a way either in a Google kind of quiz or just as a upload a document, upload a photo of the work out of your book at a resolution where I can actually read it for each of those bigger, chunkier ones at the end of each topic. So that's what we're going to be going through. So let's actually talk about networks. So networks are everywhere around us. The internet is a network. Road networks, that's why Google Maps works. Even social networks connect all of you with each of your friends and then your friends with their friends and somehow keep that all related. Graph theory has been around since the 1700s, probably before they even thought of networks, and it's the bigger picture topic. I did some graph theory at uni and I find it quite enjoyable. The other thing is that graph theory does flow on then, and networks flows into things to do with task management, prioritizing activities in an order that makes sense, and of course that then leads to efficiencies and money saving. At its most basic, a network is a connection of points and lines. Oh, and I should say all of these notes are going to be available digitally, so you don't need to try and copy it down during the video or pause it. I will try and upload these. I will upload these after each of these videos or with the video if I can. So a network is a connection of points and yeah, they're called lines, but as you can see, they're usually not even straight. So the points that we have are called vertices, and then the curved pieces are called edges. That are the proper names. And of course, a single vertex is singular, vertices is the plural. So we can have disconnected or not connected networks, but most of our topic we will just assume for the sake of simplicity that they are connected unless you are specifically told otherwise or there's a diagram to show you otherwise. Some networks will have weights attached to the edges. So some of the edges here may relate to how long it takes to travel. It might relate to just distance in kilometers. It might be a cost. It might be all sorts of things. Just depends on the question. Obviously, some of my hand-drawn drawings aren't going to be perfect. Again, we'll find situations where my dots don't join up. They are supposed to join up. The other kind of upgraded network diagram we might get is a directed network where there are arrows. Now my gut instinct again is I always want to draw my arrow on the end of a line, but that is actually quite unhelpful because it kind of runs into the dot, and if there's a lot of ones there, put the arrows in the middle like we do with kind of parallel lines. We often put the arrows in the middle. These are just to show which directions are allowed to be traveled along. So in this graph here, my mouse will come back. Oh, it's gone back to being, here we go, that's a slightly larger one. You can never get to A, but if you start at A, you can go to C and then to B or just straight to B in one go. Now, the degree of a vertex is described as the number of edges that are plugged into it. Whether they're incoming, outgoing, it doesn't matter. So the degree of vertex A here would be, well, it has two lines, lines. So we'll call it degree is 2. Now, although there is some theory on some other stuff to do with paths and trails, I'm going to leave that for another lesson because this first little exercise doesn't require you to use any of those concepts. And I will be setting an additional task for you guys to do, which is to do with signing into Maths Online. You should have got an email from me yesterday with your username and password, but I'll put that as an additional instruction for today.